The replacement pin has now been permanently mounted inside this socket, and this socket is ruined. So that's not completely what I was hoping to happen. Yeah. Let's just try that again, shall we? So, the next thing I want to do with this C64 is to fix something that's been annoying me, and that is the power LED. I'm sorry if you can hear the fireworks. It's currently New Year's Eve, and it's 6 hours until midnight, but people are already doing fireworks, I guess. So this C64 is currently off. As you can see on the LED, there's no light. But I will turn it on shortly, and you will see that even though the C64 is on, the light's going to be really, really dim. So let's have a look. Okay, so let's see what happens when I turn it on. There we go. So we can see the light, and I guess we can see it here as well. Even there, but it's very, very dim. And I mean, straight from above, like even by looking straight at it, it's kind of hard to see, especially if it's a little bit light in the room. So anyway, what I figured we could do is I'm not sure if it's the resistor that's too strong for this LED, or if it's just this old LED that has bad brightness. So what we'll do is have a look at the schematics, find the current limiting resistor for the LED, and have a look at that. And we'll just try and hook up a new LED and see if that shines brighter. And if it's not, we can have a look at if we have to desolder the old resistor or change some values. So let's get started. I'll start by opening the case. This is already unscrewed as I've been working on it for a while now. So we'll just open it up and disconnect the keyboard, and we'll disconnect the power LED for now. And let's just quickly put that to the side. We can have a look at the board. So let me get a close-up. There's a lot of fireworks going on outside. It's pretty close as well, I guess. So we're currently looking at the power LED connector right here, and there's a couple of diodes, I guess, and there's a resistor right there, R39. If I move this for a little bit, so let's have a look at this this schematics I found. So this is from schematic 251138 on simmers.net. And this is just the LED connector section. And as you can see, we have the 1, 2, 3 pins on the LED header. Of course, just 2 of them are wired up to the LED. And as we can see, there is a current limiting resistor right there on the 5-volt line, and it's called R39. And it's a 390 ohm resistor. So let's see if that's the resistor we have on the board. I think it was, and it is. That is R39. So we can quickly check the value, I guess, just to be even surer. We're expecting 390 ohms, so it should be there. And there we have 0 ohms on the pins. So let's try this resistor. And that is 394. So that looks like the correct resistor and the correct value. Now what I think we'll do is just hook up a modern LED to these 2 pins, and we'll have a look at the brightness. Guess we can have a comparison between the stock LED and a brand new one. But actually first we have to remove the old LED from the case, so let's do that next. So this is just the top case on the desk, and this is the LED, and it has this black fastener around it, and I think we need to loosen that from the underside, so we'll have a look at that. The thing is that this black part here needs to come off somehow, and I'm not quite sure how, but we'll have a try with some tweezers, maybe a knife, something like that. Let's give it a go. So I found some tools. Let's see if I can try this and not block the camera as well. So the whole thing is fairly loose. I'm not sure how this lip is fastened. There we go. Okay, so that was pretty easy. So it's just it has some, it's not threads, but it has some grooves inside the ring, which just holds on to the edge of the clip there. So with that loose, I guess we can just push the LED into the case from the other side. Or maybe not. I think that is how you do it. So when I press down, it expands this this lip on the inside, and I think I just need to press the black part and the LED at the same time and get it to expand enough. So maybe we can help with the knife. Oh, I don't want to break it. It's actually really tricky. There we go. Let's hope I didn't break anything. So the LED is now loose, and it's just this bracket left, which we can, if we squeeze that together, we can put it through, but we don't really have to do that because that's supposed to be in there on the new LED anyway. So I have some resistors here. I have a few different values, but the closest one is 470 and 330. So I don't have 390, but I think we can still do a comparison to see if a new LED lights brighter than the old one. So I think maybe we should just go with 330 and actually have a 330 ohm resistor on this breadboard already, so we can just use this. This is by no means an optimal storage method for resistors. But oh well. So I have this breadboard and I have my multimeter again. And as you can see, this is 328, so close enough to 330. And let's wire up some 5 volts and some pins, and we'll test this out. Okay, so let's use my crappy wires. So I'll actually just hook this, this 5 volt directly to this pin. I'll do the same with the ground. I'll put that in ground. So let's hook up the power supply to red and ground, which is blue. So that's hooked up. An LED usually should usually be supplied with, I don't know, like between 10 and 30 milliamps at the most. So let's just start with a maximum of 30 milliamps here and 5 volts. Let's just turn it on and see what happens. Okay. So that is very dim. So it is lighting up. It's doing something, but see how dim that is. That is so dim. Really, really dim. And that's with less resistance and a higher current than it usually has. And actually my power supply is barely reading 1 milliamp for this LED now. So now let's find one more resistor and some new LEDs, and we'll compare. Found one more resistor, so we'll just add that in here somewhere. Let's do there, and let's just use, I don't know, let's use a row on this side, I guess. That's fine. And we'll take ground, and we can add ground to this row. What's going on there? Found a couple of assortment boxes here with some of red, blue, yellow, and I have even more in here, so I have green ones too. Okay, so this is a modern LED. So let's try this. Let's get the wrong. Let's get the right orientation. Oh, look at that. Okay, so my PSU is now measuring 12 milliamps on the output, and that's for both LEDs. It was barely reading 1 for just this one. And as you can see, this is, it's glowing up on camera, but it's it looks more realistic in real life. The current is higher now than it would be in the C64, so it's going to be a little bit dimmer than it is right now, which is probably that's perfectly fine, to be honest, because this is pretty bright. It's also pretty nice. Yeah, that is very bright as well. Let's do a yellow one. seem to be about the same level. Maybe this is a little bit dimmer, the yellow one. These have much shorter legs actually. Let's try this green one. That's pretty good. That's actually very decent. And maybe a green LED for indicating that the machine is running is actually maybe even better than a red one, to be honest. So maybe we should go with green. Let's check this one as well. Oh, that's very intense. Yeah. I mean, I don't know. White LED, it's kind of boring. And currently, I am tempted to go with this green one. I saw that some online shops are actually selling LED replacements of different colors. If you don't want to do this yourself, you can buy the whole. You can basically buy this, the finished LED with the leads and the connector finished. So it's an easy replacement. Anyway, we definitely confirmed that changing the LED is gonna increase the brightness, so we don't have to change the resistor on the motherboard. So let's continue now with I think we'll just use this we'll use this wiring as it is. We just cut this LED and we solder it onto these wires and put on some new heat shrink, and we're good to go. So I want to keep this I want to keep the wiring in this as long as possible, so it's easier when we have to take the C64 apart. So I'll just cut all the way at the top here actually. This old LED is not very good anyway, so we throw that away. Let's just get some solder on these. There we go. Nice and tinned. Like that. And now we need to remember the new heat shrinking. I forgot that enough times to usually remember it now. So I have some new heat shrink here. We don't need much. Let's do, I don't know, let's do a couple of those. By the way, I have that new perifractic Sid song he made. It's just stuck on my mind. It's annoying, but it's also pretty good. I'm not gonna sing it, not even gonna hum it, so we're safe. So let's also put this heat shrink actually on the wires before we forget. So the top one here is the red one. It actually turns around back there. So the bottom one is ground and the upper one is 5 volts. Now let's cut this to a nice length, I guess somewhere around there. Oh, one leg flew away. So the LED has a flat side, which is hard to see on the camera, but it is this one at the bottom here. So this goes this way, and I think I can just tap the leg there with the soldering iron, and we're probably and we'll probably be good to go. There we go. Now let's put some solder on this LED as well. Come on. There we go. Whoops. Okay. Seems to be nice and solid, I guess. Okay, it's all good. I'm powering on the power supply. Turning on the output now. And there we go. Nice. Nice and green. Got my sexy lighter. So, let's see. Yeah, that should be good enough. Okay, so let's see if we can get it back. So some of these LEDs are not, well, some are like a tiny bit wider than others. So let's see if this actually goes nicely into this socket. Let's just make sure we have the ring for the inside, which we do. That's on the cable here. And then let's just try and insert this. I think that's it. Let's have a look at the front side. It's pretty good. Doesn't look very green at the moment, but it's definitely looking good inside there. So let's get this ring. Let's just make sure one more time that it's all in there. There we go. Push down on this ring. Oh, I need to apply even pressure. There we go. I think that's on there good enough. We also how hard it is to get that LED out of the the outer ring anyway. So I think we're pretty safe. I think that looks pretty good. A nice green tint. So let's find the motherboard and hook this up and give it a go. Let's just get the keyboard connector. There we go. And where's our LED? Which is which again? So there's actually a 1 and a 3 on the motherboard, and the connector also has some numbers. Well, it has one number, so that's 1, which means that the red wire is 1. So it goes in like this, which means that the red wire is supposed to be towards the back of the case. And the third pin is the empty one. There we go. Okay. Let's hook up the power. Let's make sure it's off. It is. Let's hook up the power. And maybe the video as well. I can capture some footage if it's working. There we go. Let's go. Look at that. That's pretty nice. I like that. So it's easier for me to see that the C64 is on. It's easier for you guys to see on the camera. So it's a nice nice upgrade. And it's a green light, so that means everything is okay instead of the red light. Let's see if we get an image here. Oh, there we go. Well, that's perfect. So this still has my my Merry Christmas 64 kernel, which we modded in a separate video. I guess I can link that up in the corner. Where is it? Like there-ish, if you look at that camera, and that way if you look at that camera. I'm sure you can find that video in maybe in the recommended video sections, or on my, just go into my channel and find it. And we're actually gonna do some more ROM hacking, because I'm not gonna use this Christmas kernel. That was just for educational fun. But I will make one change, and we will do that next actually, and that is to modify the standard font color on the C64. I mean, this is very readable. This is white on red, which is good. But the default colors, which are light blue on dark blue, is not very contrasty. So this is very nice. So I'm very happy with this modification. So let's move ahead and do the changes in the kernel that I was talking about. So we're back in Visual Studio, and we're basically where we left off in the Merry Christmas 64 kernel video that I made. There's probably already been a link on the top right corner in the video, and I'll leave a link in the description as well. Even though this Christmas kernel was kind of a gimmick, what I really wanted to do was to take the original color scheme of the C64, but actually swap out the text color. Because when I do videos and I capture from the C64, the low contrast between the background and the front color is very annoying. It's hard to see on video. So I'll swap back to the standard kernel, and we'll just do the text color modification this time. This is the starting point, and as you can see, there's low contrast between the front color and the back color. And there's some theories to why that is the case. Yeah, so I watched a video by 8-Bit Show and Tell. He goes through all the kernels. He mentions something about the color choices that were made, and apparently there's a reason behind it. There's also some additional info in the comments, so I urge you all to check out that video as well. I'll leave a link to it in the description. It's very interesting. This channel is amazing, so make sure to subscribe. So what I usually do when I'm trying to show something off on camera on a screen capture is that I change the color to white like this, and that obviously makes it way easier to see. That's what we're gonna do, so we don't have to do that every time, because I usually, well, sometimes at least I forget, and it also doesn't change the color of the text that's already on screen. Now I'll load the kernel into this hex editor, And I'm not going to go through the details this time since I did that in that other video I was speaking about. But basically what we did to find the location of the font color was to look at the source code listing for the kernel. And this is where we found this code right here. This is the code we need to find in the hex editor to modify. And we know we are looking for a load A instruction and then an immediate value of E, which is the color for light blue, as you can see in this table. So load A, this is the 6502 opcode reference, well, one of them, and this is all the load A instruction, and there are different addressing modes. We are looking for a immediate addressing mode instruction, which is this right here, and that decodes to A9. Basically what we will be searching for is A9 0E, and we'll just do that now. Search for A9 0E, and again I go way more deep into this in that other video, so I urge you to watch that if you find this interesting, but I won't do it in this video. So what we'll do now is just change this value, and according to the reference table, white is going to be hex 1. So I'll go back into the hex editor, we'll change this 0E to 01. Then we will do a save, KERNAL ROM, save, replace. Let's jump back into Visual Studio and start the emulator. And there we go. That's so much more readable. So that's basically the whole fix. Just for fun, I think I'm gonna change this text as well, because it's just fun. So let's go back into the hex editor, and this time we will do a search for Commodore, which takes us to the text, and I think HAG'S LAB, that fits perfectly in there, so let's go with that. Save again, kernel, save. We'll try this once more, and there we go. HAG'S LAB 64. So this is the C64 I'm going to use for my projects and videos, and this is going to make it a lot more easier to see on camera, well, on capture, and also on camera if I show it on an external monitor or something. So what I'll do now is just burn this kernel image onto an EEPROM. I got these EEPROMs of FleaBay, and these are Atmel 8028C256. They're obviously used before because the pins are tinned, and they're probably removed from a soldered board of some kind. So these haven't been socketed. They seem to work fine because I used them in my last video, and I've tried multiple of them. But if we take a look at my microscope here, we can see that this actually has a broken pin, and that was barely hanging on there, and that happened when I was programming the chip. So what I think we'll do is actually try and repair this chip and then use it for the modified kernel. So let's just do that quickly. So this is a 74LS74 APC some kind of logic chip that I swapped out on my C64 already because this was not working. So let's just cut one of these pins and solder it onto the EEPROM. I'll try and cut as high as possible on the chip here, so we can salvage as much of the pin as possible. There we go. It almost flew into my microscope. So that's the pin we'll use, and this is already tinned basically. Let's just apply some flux to the pin, and let's just hit this with the soldering iron and some solder. There we go. And see if I can get this pin. So let me get it to the right. I found it. It flew away. It happens all the time with these small legs when you try and use the what are these called? What are these called again? I'm having a total blackout. Tweezers. Tweezers. Let's try this again. Okay, so that did actually fasten, but I don't know if I'm happy with that. What I'm thinking is if I use a socket like this and just try and keep the pin in place, I can fix the solder joint a little bit without the pin falling out. So I'll just add this pin header on the socket like so, and hopefully that will keep the pin from moving, and we'll redo that solder joint. Let's give it a go. That might have soldered to the socket. Crap. That's not what I wanted. I applied too much solder. So let's get the manual solder sucker out and I'll try and remove some. Okay, so I think we may have ruined the socket. So the replacement pin has now been permanently mounted inside this socket, and the socket is ruined. So that's not completely what I was hoping to happen. Yeah. Let's just try that again, shall we? Should I just use one of these LED leads that I trimmed? I mean, they are pretty much the same width, and then we can trim the length afterwards as well. Let's give that a try. that might actually have worked pretty nicely. So yeah, that sounded very good. So let's just trim this to the right length, which is about there, I think. There we go. Maybe a tiny bit more. Like that. Okay, let's see if we can get this EEPROM to program. Put it in the programmer. I have the kernel loaded up into the flash program. As you can see, it says HAG'S LAB there. So let's just burn this now and give it a go. So I think that programmed correctly. So let me find the adapter in the 64. I'll take out the adapter and we'll swap the Christmas ROM for this new ROM, and then we'll put the adapter back in the C64. Let's get this old EEPROM removed. So this is the Christmas ROM, well, the Christmas kernel. I'll put this to the side. Okay, let's finally see if we can get this EEPROM in there. So the notch is upwards, so let's do the same on the chip. Try and get these pins aligned so I don't ruin them again. I think they're all in there nicely now. I'll press. And I'm not sure if we have good contact on the pin we added, to be honest. It won't go in there completely, but let's give this a try. If it doesn't work, I'll take one of the other EEPROMs and I'll try and fix this better if we absolutely need it at some point. Let's try. Let's insert this adapter into the C64 and let's just cross our fingers and hope that it works. So let's close it up, hook up the video and power. There we go. Let's first see if it turns on. Green light, that's good. There we go. So that did actually work then. Well, that's good enough. So we have HAG'S LAB at the title, and we have white text, so we don't have to do that every time. Very nice.